Hi, welcome to this video. This is a new section for the course, and in this section, we are going to look at maxima and minima. We are going to usually use mean value inequalities like AMGM inequality, Cauchy's inequality, and so on to try to find maxima and minima of quantities. So now this is a problem solving section. I'll give you some examples. We'll work through some questions in this video. The best way to learn would be if you pause the video after the question is stated and try it yourself. And then when you have tried it yourself and done it, or if you're not even able to do it, then you can go through the video and see the solution. That is probably the best way for you to learn. Let's begin. The first question is this. Suppose there are three positive reals A, B, and C, which satisfy A is greater than equal to 3 and AB plus BC plus CA is equal to 16. We want to find the minimum value of 2A plus B plus C. So let's think about how we go about doing this. We have to target this expression 2A plus B plus C. So 2A plus B plus C can be written as A plus B plus A plus C, right? So if I group these two terms together, I have to find the minima of this, right? So minimum of the sum of two quantities, right? We also have these conditions. So we have ANGM, which we'll use a lot through this video. ANGM inequality for positive numbers says this. So if we can say A plus B, it will be greater than equal to 2 root over AB, right? And equality happens when A is equal to B. So let's think about how we can apply that here. We have the sum of two quantities and we have to find the minimum value of this, right? So let's look at what the product is. A plus B times A plus C. The product is equal to A square plus AB plus AC plus BC, right? And we can see here that AB plus BC plus CA is 16. So this is A square plus 16. And we know A is greater than equal to 3. So this will be greater than equal to 9 plus 16 equal to 25, right? So we can immediately now solve the question because we can say that A plus B plus A plus C by 2 should be greater than equal to root over A plus B, A plus C, which is greater than equal to root over 25. Therefore, we get 2A plus B plus C is greater than equal to twice of 5, which is 10. Because this is 5 and you can say this 2 times this. So 2A plus B plus C will be greater than equal to 10. And the equality will happen when A plus B is equal to A plus C. The equality in AMGM happens when the quantities are equal. So these two quantities must be equal. That implies that B is equal to C. And if B is equal to C, and here you can say that A should be 3 for this to be 25, and A is equal to 3, you can solve this equation to find that the three values must be B is equal to C is equal to 2, and A is equal to 3. That will ensure that AB plus BC plus CA is equal to 16. So what we have found is the minimum value, and we have also found when that minimum is achieved, right? So that is a crucial step in all of these maxima minima problems. You cannot just be satisfied with an inequality. You also have to see if the lower value or the highest value is actually attainable or not. And when does that happen, right? Okay, let's move on to the next question. This is question number 2. Question 2 says, suppose there are three real numbers A, B, C, which satisfy 2 power A plus 4 power B is equal to 2 power C, and 4 power A plus 2 power B is equal to 4 power C. We have to find the minimum value of C. find the minimum value of C. Okay. So now here what we can see is if A and B and C are linked together in an exponential function, and it is 2 power A and 4 power B and stuff like that. So instead of trying to directly find the minimum value of C, we can try to find minimum value of 2 power C, right? Minimum value of 2 power C, right? And in order to do this simply, it would be nice if we can convert the exponentials to standard algebraic expressions. The way you can do that is by calling 2 power A as X, 2 power B as Y, and 2 power C as Z, right? Then the equations here will transform like this. They will become X plus Y square equal to Z. And the second equation will become X square plus Y is equal to Z square, right? So these are the two new equations once we have made a change of variable here. And we have to think about what is the minimum value of Z, right? Minimum value of Z. So from the second equation, we can say Z square minus Y is equal to X square. And from the first equation, we can say that X is equal to Z minus Y square, right? So using these two relations, we can equate X and X square by saying Z minus Y square whole square should be equal to Z square minus Y. Expanding it, we get Z square plus Y power 4 minus 2ZY square is equal to Z square minus Y. Z square gets cancelled, and we have basically a way to get 2Z, right? So what we get is Y power 4 plus Y by 2Y square is equal to Z. Just solving for Z here, we get Y power 4 plus Y by 2Y square is equal to Z. And we have to find what? We have to find the minimum value of 2 power C, right? We have to find minimum value of Z, right? So Z is equal to Y power 4 plus Y by 2Y square. Let's try to apply some ANGM inequalities here. I want to get the minimum value of the numerator here. Then only I'll be able to somehow estimate Z. So how can I apply AMGM? If I directly do AMGM here, the powers will be off, right? The powers will be weird because it will become Y power 5 by Y power 5 root of that, right? So what I mean by that is this. I will just do it here. So suppose I apply AMGM directly to these terms. So I'll get this greater than equal to Y power 4 times Y. So that is not helping us. We are getting Y power 4 plus Y is greater than equal to twice of Y power 5 by 2. That doesn't help us because that doesn't cancel the Y square in the denominator. So in order to cancel the Y square, you can write Y power 4 plus Y as Y power 4 plus Y by 2 plus Y by 2 and apply ANGM on these three terms. So you can say this divided by 3 should be greater than equal to cube root of Y power 4 into Y by 2 into Y by 2. Now why is this better? Because here you will get Y power 6 by 4 and cube root of Y power 6 will give us a Y square, right? So we can say Y power 4 plus Y is greater than equal to thrice of Y power 6 by 2 square cube root of this, right? So which is equal to 3 times Y square by 2 power 2 by 3, right? So Y power 4 plus Y is greater than this quantity. So we can say it is greater than here 3Y square by 2 power 2 by 3 and 2Y square is in the denominator. So Y square gets cancelled and you have 3 by 2 power 5 by 3. So Z is greater than equal to this. Z is greater than equal to 3 by 2 power Y power 3. And this equality happens when this equality will happen only when Y power 4 is equal to Y by 2 because AMGM is equal when the terms are equal, right? So Y power 4 should be equal to Y by 2 for equality. So you get 2Y cube is equal to 1 and Y cube is equal to 1 by 2 power 1 by 3, right? Y is equal to 1 by 2 power 1 by 3. So we can find Y and X and Z. So When y is this, we can find the x value also, because z is becoming equal to this, right? We have found basically the minimum value of z, but the question said we have to find the minimum value of 2 power c actually, right? So we can say now that z is greater than equal to, we have gotten 3 by 2 power 5 by 3, and z was 2 power c is greater than 3 by 2 power 5 by 3. So if you take log, you get c log 2 is greater than log 3 minus 5 by 3 log 2, and c is greater than log base 2 3 minus 5 by 3. So that is the minimum value of our c quantity here. Notice what we have done. We just simplified for z. We simplified for z and got an expression like this using the two equations. And then I applied AMGM on the numerator, but not directly, by doing it on 3 terms instead of 2 terms. And we got this by 3 is greater than equal to cube root of y power 6 by 4, right? And why was this better? Because here you got a y square term which got cancelled here, and we got a numerical value for the minimum value of this. So I hope you understand what we have achieved here. Let's move on to the next question. Question number 3. Suppose U, V, W are positive reals satisfying U times root of VW plus V times root of WU plus W times root of UV is greater than equal to 1, right? Find the minimum value. Find the minimum value of U plus V plus W. U plus V plus W. Okay. So now looking at this question, you can see that the target expression that we have here is looking very different from the expression that we have here. So this is the expression given in the question. It has U and the roots of VW and stuff, but the target expression whose minimum value we need is looking very different, right? So our first thought should be to convert this expression and try to make it look like this at least, right? So unless we can do that and make it look similar, we cannot do an inequality on this, right? So how can we make this one look a little similar to this? By AMGM, of course, we can say that V plus W by 2 is greater than equal to root VW, and similar inequalities for these other roots also. Therefore, we can say that instead of root VW, we can say U times V plus W by 2 plus V times W plus U by 2 plus W times U plus V by 2 will be greater than equal to U times root VW plus V times root WU plus W times root UV. This inequality is true because of AMGM, right? And now we have here something like this, which can simplify as twice of UV plus VW plus WU by 2 is greater than equal to this expression U root VW plus V root WU plus W root UV. We know that this is greater than equal to 1. So we can say this is greater than equal to 1. So what we get from here is that UV plus VW plus WU is greater than equal to 1, right? Because this 2 gets cancelled. So we have a nice result here, which is a quadratic expression UV plus VW plus WU is greater than equal to 1. And now we have to find minimum value of this. Now it is obvious what we can do. We can say U plus V plus W whole square is equal to U square plus V square plus W square plus twice of UV plus VW plus WU. And we can simplify this using AMGM as well. So I'll do that on the next screen. We have U square plus V square plus W square plus twice of UV plus VW plus WU. That is what? That was our U plus V plus W whole square, right? And if I simplify this, I can say this can be written as half of u square plus v square plus half of v square plus w square plus half of w square plus u square, right? Plus twice of uv plus vw plus wu. Now, all of these terms are greater than equal to uv, right? By AMGM on these two terms, we can say it is greater than uv, this is greater than vw, and this is greater than wu. So we are getting that the overall expression is greater than equal to thrice of uv plus vw plus wu, right? And we know already that this is greater than equal to 1. So this is greater than equal to 3. We have proved earlier that uv plus vw plus wu is greater than equal to 1. So we are using that here. So now we are getting that this whole expression is greater than equal to 3. And this expression was actually equal to this. So we can get that u plus v plus w should be greater than equal to root 3, right? I hope you appreciate how we got there. The initial expression that we had was very different to the expression which we are targeting to minimize. So what we did was applied AMGM on the initial expression and ended up with the condition that uv plus vw plus wu is greater than equal to 1. And then we looked at the target expression and simplified it by squaring, right? Let's look at another problem. This is question number 4. Here we have A, B, C are non-negative reals. A, B, C are non-negative reals, and we want to find the minimum value of root over A by B plus C plus root over B by C plus A plus root over C by A plus B. Okay. Now think about it. Because of the way this initial expression looks, there is no direct inequality that I can apply. Like, there is no symmetry. I mean, it is symmetrical to a certain extent because B plus C plus A plus B, but there is no direct way to apply any inequality on this. So what should we do here? We have to basically transform the target expression. Transform this expression to make it look like something which we can work with, right? So one way to transform it would be to try to rationalize the numerator. If I multiply by root A up and down, I will get A by root over A B plus C plus B by root over B C plus A plus C by root over C A plus B, right? Okay, so now we have a product of terms in the root, right? We have a product of two terms in the root. Now at least we can do something about AMGM and stuff, right? So we can say A times B plus C is less than equal to, or root over A times B plus C is less than equal to A plus B plus C by 2, right? So we are getting this expression which is equal to A plus B plus C by 2. So this is AMGM on these two terms, right? A and B plus C. So then we can say the reciprocal 1 by root over A times B plus C will be greater than equal to 2 by A plus B plus C, right? And now we can, from this it implies that if you multiply the top parts by A, you get A by root over A into B plus C will be greater than equal to 2A by A plus B plus C, right? Similarly, you can prove that B by root over B into C plus A will be greater than equal to 2B by A plus B plus C. And lastly, C by root over C into A plus B will be greater than equal to 2C by A plus B plus C, right? So because we have gotten these three inequalities by applying AMGM on the denominator, we can say this is greater than equal to 2A plus 2B plus 2C by A plus B plus C, the sum of the three individual inequalities, and which is basically greater than equal to 2, right? Now, one key thing, we have already solved this. We have gotten that this is greater than equal to 2. But one thing to notice here is that here in this inequality, 2 cannot be attained. The minimum value of 2 cannot be attained because the minimum value will come when the quantities are equal, right? So when the minimum value will happen when A was equal to B plus C, And similarly, B was equal to C plus A and C was equal to A plus B. But that implies that A plus B plus C is 0, right? These three inequalities together imply that A plus B plus C is 0, which will mean that if they are non-negative reals, that it cannot be true, right? Because that will ensure that they cannot be all positive. So that will mean that A is 0, B is 0, C is 0, something like that, if they are non-negative reals, right? But that is not possible in this expression, right? In this expression, it is not possible because the denominator is not defined. If A or B or C is 0, it is not defined. However, in the original expression, the denominator is not like that. So actually, it is possible that one of ABC could be 0. One of ABC could be 0. And if you put, say, C is equal to 0, what happens? It becomes root over A by B plus root over B by A. That's it. And that is greater than equal to 2, right? That is true whenever A is equal to B. So basically, in the overall expression, the minimum value of 2 can be attained. And this will be attained when A is equal to B and C is equal to 0, perhaps. You could switch the variables and it could be A is equal to 0 and B is equal to C. So you have to be a little careful about when the minimum happens. You can't just be happy with the minimum value. You also have to think about when the minimum happens. You have to realize that A and B and C, none of them can be 0 in this expression because the expression itself is not defined for any of them being 0. So the minimum cannot be attained here, but actually the same minimum can be attained in the original expression because the original expression allows one of ABC to be 0, right? Two of them I don't think can be 0. If C and A are 0, you'll get this becomes 0. Only one of ABC can possibly be 0. And in that case, if one of them is 0, the other two have to be equal, and then the minimum value of 2 is attainable, right? So that is the analysis for this question. The first step here was to convert the initial inequality into a form which we can work with. We rationalized and did that, and then we applied AMGM on the denominator like this. So I hope you have learned something from this one. Let's move on to the next question. We have to find the minimum value of question number 5. Find the minimum value of 1 by sine square A plus 1 by sine square B plus 4 by 1 plus sine C. Okay, in any triangle ABC. In any triangle ABC. Okay. Now, okay, the first two terms are similar to each other. The third term is very different, right? So what we can do is think of the first two terms in the beginning together, and we can say by AMGM, we know that sine square A and sine square B are positive quantities in any triangle. So this will be greater than equal to twice of the root of the product. So that will be 2 by sine A sine B. Correct. So this is by AMGM on these two quantities. And then we can write the overall expression 1 by sine square A plus 1 by sine square B plus 4 by 1 plus sine C is greater than equal to 2 by sine A sine B plus 4 by 1 plus sine C, right? Now, this expression on the right hand side here, you can say 2 by sine A sine B plus 4 by 1 plus sine C is equal to 4 by, this is 2 times sine A sine B. I am multiplying this by 2 up and down, and 2 sine A sine B using trigonometric identities can be written as cos A minus B minus cos A plus B. So this is becoming 4 by cos A minus B minus cos A plus B plus 4 by 1 plus sine C. Correct? Now, we can write this as 4 by cos of A minus B and cos of A plus B. A plus B is equal to 180 minus C in any triangle, pi minus C, and cos of pi minus C is minus cos C. So minus of cos of A plus B will become plus cos C. right? By using that identity. So you get 4 by 1 plus sine c, right? At this step, we can say that this term will be greater than equal to 4 by 1 plus cos c plus 4 by 1 plus sine c, because cos of a minus b is less than equal to 1, right? Since cos of a minus b is less than equal to 1, if we replace this with a larger term, this is actually lesser than this, right? So that's why we have written greater than equal to this, right? And the equality happens when a minus b is 0 or a is equal to b. That is the time when we'll get an equality here, right? So we are getting 4 by 1 plus cos c plus 4 by 1 plus sine c is lesser than equal to the target inequality that we had, right? So let's work on it in the next mean. So we'll do it here. We have this expression 4 by 1 plus cos c plus 4 by 1 plus sine c, right? Correct. So now let's think about the expression. It's 4 common 1 by 1 plus cos c plus 1 by 1 plus sine c, right? So if you think about it and think of this whole term as a and this term as b, we have 1 by a plus 1 by b, right? And we can say that 1 by a plus 1 by b will be greater than equal to 4 by a plus b. Why? Because a plus b by ab is greater than 4 by a plus b, because a plus b whole square is greater than equal to 4ab, because a minus b whole square is greater than equal to 0. See, these steps are all correct, right? We can start from here. A minus b whole square is greater than 0. That implies a plus b whole square is greater than equal to 4ab. And then take a plus b here and 1a plus b here and ab down here, right? Then you will end up with 1 by a plus 1 by b is greater than equal to 4 by a plus b, right? So if I write this as 1 by a plus 1 by b, where a is 1 plus cos c and b is 1 plus sine c, I can write that this is greater than equal to, so 4 times 1 by 1 plus cos c plus 1 by 1 plus sine c is greater than equal to 4 times, 4 is a constant here, and the inside part is greater than equal to 4 by 1 plus cos c plus 1 plus sine c, which is equal to basically 16 by 2 plus sine c plus cos c, right? And the maximum value of sine c plus cos c is root 2, which happens when c is equal to pi by 4, when sine c is 1 by root 2 and cos c is 1 by root 2. So we can say that this is going to be greater than equal to 16 by 2 plus root 2, right? Because if you take the maximum value for the term in the denominator, the quantity that you get will be lesser than the other possible values, right? So we'll get 16 by 2 plus root 2. If I rationalize this, 16 by 2 plus root 2 multiplied by 2 minus root 2 up and down, you will end up getting 2 minus root 2 into 2 plus root 2 is 4 minus 2. So that is 2. So this will be 8 into 2 minus root 2, right? So ultimately what we are getting is that this thing is greater than equal to 8 into 2 minus root 2. And the equality happens when c is equal to pi by 4. And earlier we had already established that a must be equal to b for equality to happen, right? I hope you have understood what is happening here. Correct. Uh, let's go on to the next one. We have basically these. Suppose x1, x2, x3, x1, x2, x3 are non-negative real numbers, are non-negative real numbers such that x1 plus x2 plus x3 is equal to 1. We have to find minimum and maximum values of x1 plus 3x2 plus 5x3 multiplied by x1 plus x2 by 3 plus x3 by 5. So first we'll handle the minimum case, minimum value of this expression, right? Now think about Cauchy's inequality. Cauchy's inequality says that a1 square plus a2 square plus a3 square multiplied by b1 square plus b2 square plus b3 square is greater than equal to product of a1 b1 plus a2 b2 plus a3 b3 whole square. This is Cauchy's inequality for three variables. Now what we will do is we will directly apply Cauchy's on this. How do we apply that? We will say a1 square is x1, a2 square is 3x2, a3 square is 5x3, b1 square is x1, b2 square is x2 by 3, and b3 square is equal to x3 by 5, right? So applying Cauchy with these terms for a1 and b1, what we will get is this term here is directly a1 square plus a2 square plus a3 square. So we'll just write x1 plus 3x2 plus 5x3 multiplied by x1 plus x2 by 3 plus x3 by 5 should be greater than equal to, now we do the a1 b1 terms, right? So it should be greater than equal to root of x1 into root of x1 plus root of 3x2 into root of x2 by 3 plus root of 5x3 into root of x3 by 5 whole square. And this actually simplifies nicely and becomes x1 plus x2 plus x3 whole square, which we know is 1, right? So is equal to 1. So we are getting that this quantity is greater than equal to 1, right? And the equality will happen when the vectors that are formed are parallel to each other, right? So a1, a2, a3 vector and b1, b2, b3 vector have to be parallel to each other. So you cannot take a direct proportionality because you will get something wrong. If you do direct proportionality, root 3x2 by x2 by 3, x2 will cancel and it will become a root 9, root 3. And similarly for this, whereas here you're getting a 1, x1 and x1. So the only way it will happen is x2 and x3 are 0. We can say x1 is 1, x2 is 0, and x3 is 0. In that case, the two vectors here will be parallel because both are the same vector actually. It is 1 for a1 and 1 for b1, whereas a2, a3, b2, b3 are all 0. In this case, we'll get x1 plus x2 plus x3 is equal to 1, which satisfies the conditions of the problem. And we'll also get that the minimum value will be attained, right? The minimum value of this expression is greater than equal to 1. The minimum value is attained at this point, right? We have gotten this by direct Cauchy's inequality, right? Let's look at when we try to do the maximum, right? So we have x1 plus 3x2 plus 5x3 multiplied by x1 plus x2 by 3 plus x3 by 5, right? Now what we can do here is multiply up and down by 5. You can say 1 by 5 x1 plus 3x2. The second bracket we are multiplying by 5. Why? We'll see why in a bit. We multiply 5x1. This is 5x2 by 3 plus x3, right? Now, on these two terms, the reason we multiply by 5 is because here we have x1 plus 5x3 and here now you have 5x1 plus x3. So there is a little bit of an element of symmetry here. So we want to say what is the maximum value of this expression. So this is a product of two terms. So we can do AMGM and say xy by xy is greater than equal to, xy is less than equal to x plus y by 2 whole square, right? This is AMGM on two terms. So we can say that this is going to be less than equal to 1 by 5. And when you do by 2 whole square, you will get x plus y whole square by 4 basically. So we'll say 1 by 4. And now you can say it is x1 plus 3x2 plus 5x3 plus 5x1 plus 5x2 by 3 plus x3 whole square, right? This is what we are getting. Now, here, the equality, the maximum value happens when x is equal to y. So we have to say that this should be equal to this for maximum, right? So if I try to solve that, I'll get x1 plus 3x2 plus 5x3 should be equal to 5x1 plus 5x2 by 3 plus x3, right? So if you think about it, this is becoming 3x2 minus 5x3 is 4x2 by 3 is equal to 4x1 minus 4x3, right? So this equality is there. So we can cancel 4 and we'll get x2 by 3 is equal to x1 minus x3. And we also have x1 plus x2 plus x3 is equal to 1, right? So if I use this now, we will get basically x2 is equal to 3 times x1 minus 3x3. And we put that x2 here, we will get basically x1 plus x3 plus 3x1 minus 3x3 is equal to 1. You get 4x1 minus 2x3 is equal to 1, right? Correct. So one possible way in which this can be satisfied is if x1 is equal to x3 is equal to half, right? Because we are getting, if x1 and x3 is half, we will get 4 into half, which will be 2, minus 2 into half, which will be 1. And then this equality is true. And then if x2 will be 0. So basically one possible way in which we attain the maximum value is when x1 is equal to x3 is equal to half and x2 is equal to 0. In that situation, we will have a maxima of this. We will attain the maxima basically, right? So what I want to see here is what is that maximum value? That maximum value will happen when x1 and x3 are both half and x3 is 0. And let's try to estimate the maximum value, right? So I'll just write it here. x1 is equal to x3 is half and x2 is 0. This is when the two quantities inside the bracket are matching, right? So what is the expression here? 1 by 20. Inside the bracket, we have 6x1 plus 6x3 plus this is 3 plus 5 by 3. So that is 14 by 3 x2 whole square, right? Now, 14 by 3 is not 6x2, but we know that we are dealing with a case when x2 is 0, right? So this is equal to basically 1 by 20, 6x1 plus 6x3 plus 6x2 whole square. Why? Because in this situation, we are trying to get the maximum. So x2 is anyway 0, so we can make 14 by 3 into 6 because the value doesn't change. And we'll say this will be equal to 36 by 20 x1 plus x2 plus x3 whole square, right? And in that case, x1 plus x2 plus x3 is 1. So this will be 36 by 20 or 9 by 5, right? So basically the maximum value here, this is 9 by 5. So the overall expression is less than equal to 9 by 5, which happens when this and this are equal. And that one possible way in which they can be equal is when x1 and x3 are half and x2 is 0, right? And in that moment, the maximum value will be attained and that will be 9 by 5, right? Correct. So we are applying AMGM on these two terms to find the maxima, and we are applying Cauchy's inequality to find the minimum that we did earlier. Okay, let's look at the next problem. This will be the last question for this section. Question number 7. We are given, suppose mod of xi is less than 1 for all I going from 1 to n, right? And we are also given the condition x1 mod x1 plus mod x2 and so on till mod xn is equal to 19 plus mod of x1 plus x2 plus till xn, right? we have to find the minimum value of n. Minimum value of n. So that this condition is true, right? We have some initial information and we have to find when is this n, what is the minimum possible value of n, right? So first of all, we can write that 19 is equal to basically the sum of all the absolute values xi minus the absolute value of the sum, right? 19 is equal to this. That is the way the condition of the problem has been stated. And now we can say that obviously this thing is less than equal to summation of all the absolute values, right? Why? Because here obviously we are subtracting something positive. So it is clear that this inequality holds, right? This quantity here is less than equal to this. And we know that each of the xi's are less than 1. So we can say that this is less than n, right? Because you are adding up n of the xi's, the mods of the xi's, and n of them. So we can say it is clear that this inequality holds because of this first condition, right? So we are getting basically n is greater than 19, right? So n must be greater than equal to 20, right? It is possible that n has to be 21 or 22 or any higher number, but it is possible for n to take the value 20. Now what we want to do is we want to check whether we can arrange or we can find xi such that n is equal to 20 is attainable, right? If n is equal to 20 is possible, then that will be the lowest integer value of n, right? So what we will do now is check whether this n is equal to 20 is possible, right? So let's try to think of a way to assign xi in such a way that we can do n is equal to 20. So when n is equal to 20, we can choose xi like this. Xi is equal to 19 by 20 for 1 is less than I is less than equal to 10, and it can be minus 19 by 20 for 11 is less than equal to I is less than equal to 20, right? Notice that all of the mods of the xi's are less than 1. So it satisfies the first condition. And also you have to realize that when you take the sum of the 20 mods, the sum of the 20 mods will be 19 by 20 plus 19 by 20 and so on, so on. There will be 19 by 20, 20 times on the left hand side. So you'll get 19 here. But on the right hand side, you'll get 19 plus the mod of the sums. The sum is actually adding up to 0, right? Because there are 10 terms with 19 by 20 and 10 terms with negative 19 by 20. So basically this choice of xi definitely satisfies the second condition as well. And it also satisfies the first condition. So basically we have proved or we have gotten a group of values of xi such that when n is equal to 20, the condition of the problem is satisfied, right? Now we have already understood that n must be greater than 19. So 20 is the smallest possible value of n that we could possibly take, right? So we have shown that the minimum value of n is 20. This is a kind of proof where you do a proof by existence. You have to show that n could be 20, and we have shown an example, constructed an example where n was 20. Obviously, there could be other ways in which you could make the conditions of the problem true. There could be other groups of number xi that you could have chosen. But it is just important to choose one group. It doesn't matter if you can have any other possible values of xi on. So basically, we have satisfied the conditions of the problem and we have realized that the minimum value of n is 20. So that concludes the problem. Hope you have understood how we have solved it and you learned something from this video. We will continue our journey into inequalities. The next few sections will cover a little bit of advanced inequality. We have seen a basic flavor of inequalities earlier in the course. They were easy. We'll go into slightly harder problems now. And I'll see you in the next week.